It's a great pleasure to participate in the fourth International Conference on Applied Computing organized by UTM. Welcome to my presentation. My name is Lin Xuanqing, a PhD student at the Faculty of Computing, UTM. The topics of my presentation today is a view of human positive estimation algorithm based on convolutional neural network. It's mainly present in these four aspects: introduction, human post estimation algorithm, difficulties and development trends, conclusions. With the quick improvement of information technology and the profound convolutional neural network, human post estimation has become a popular research problem in the fields of human-computer interaction, sports science, virtual reality, etc. Human post estimation constructs human architecture by detecting join points information and predicting interjoin connections and its foundation of tasks, such as human action recognition. Human post estimation aims to automatically locate the human body parts from the images or videos. In the simple case, as shown in this figure, where only one person is in the image, or the position of the person is given. A single person algorithm should be performed to locate the human parts, such as the head, the shoulders. In short, the import is mostly 2D images or videos, and the output is typically a skeleton of the people. However, most of the previous review are focused on introduction or summarizing the traditional methodologies of human positive estimation and did not focus or analyze the CNN-based method or and doesn't cover recent development of the latest methodology of the 2020. In this paper, the goal is to analyze the key procedures of various proposed approaches and make researchers understand how deep learning can be exploited in human positive estimation tasks. All human positive estimation methodologies are first classified into two categories, 2D and 3D. 2D HPE are classified into single person and multi-person post-estimation approaches. On the one hand, the single-person approaches detect the pose of a certain person in an image due to the given position information. The object of single-person approaches is to find the key point position in that area, so it's essential to solve the regression problem. Single-person HPE is classified into three types depending on the way they predict the key points: direct coordinate decision approaches, heat-map-based approaches, and regression and detection hybrid approaches. The further utilize the output feature maps to regress key points directly, whereas the later brain generation heat maps first. The pixel value in heat map indicated the key points existent probably in that position, and then predicts key points based on the heat maps. Multi-person approaches can be classified into two categories according to their methodology: top-down and bottom-up approaches. Top-down approaches are roughly divided into two steps: human detection and single-person key point estimation. Bottom-up methods have similar steps with the bottom-up. The first step is to locate all the key points in an image, and the second step is to follow out these key points according to the person they belong to. Now let's talk about history and development of HPE algorithm. The field of human post estimation has witnessed significant progress and advancement since 2010. This section provides an overview of historical evolution and the development of human post estimation algorithms during this period. For the period of 2010 to 2012, deep learning techniques start gaining attention in various computer vision tasks, including human post estimation. For the period of 2010 13, 2015. Progress is mainly on articulated and path-based models. Notable works include DPoS and CPMS. Researchers focus on addressing the challenges associated with articulated post-estimation, where joint dependence and structural relationships are crucial. Notable work including deep-cut and hourglasses. For the period of 2018, progress is mainly on multi-person post-estimation and datasets, such as MP2 and MS-COCO. For the period of 2019-2021, temporal modeling and 3D post-estimation is mainly in progress, such as transformers, multi-pose, and HUMOR. In 2014, DISPOSE, the first neural network model, was proposed and introduced deep learning to the field of human post-estimation for the first time. DISPOSE improved the accuracy of the post-estimation regression network to solve the problem, and it's difficult to estimate complex human body parts because it's not considered local appearance in the post-estimation, but it's not applicable to the case where the resolution of the input images is related high. In 2016, CPM, convolutional post machine, is used to estimate the individual human posts for each candidate's frame separately. However, when estimation each candidate's frame individually, none of the bodies are occluded or truncated for each other, which makes the estimated joints not associated with the current body and lead to incorrect estimation. Therefore, to connect each joint with the right human body, animated the anomalous frequency outlines. The method uses integer linear programming (ILP) to perform integral on the fully connected graph of each person to derive the final post-estimation result. And in the bottom-up approaches, key-point connection is an important step, like deep cut. Deep cut is a method for obtaining pixel-wise objective segmentations from an image database labeled with bounding box annotations. Hourglass analyzes multiple consecutive frames to obtain the patterns of changes, and then builds a more accurate topology of each joint. And GCN, Graph Convolution Network, is an project capable of learning multi-scale features. The model HUMOR introduced in 2022-21 treated the human mode as an import sequence as well. And additional outputs include ground and human ground contact. VIT pose based on vision transformer for PHE and proposed a pure transformer structure. And there are several difficulties like flexible body structure, variable environment, influstered training data, and inhibition time. And there are 5 future development trends like detection for a typical joint point, improved adaptation to complex scenes, simplification of the computer's pattern, skill-based human post-estimation, semi-supervised or even unsupervised models. Though the present human post-estimation method has been greatly improved, they still need to be enhanced for better application in the real world. It's hoped that readers can be inspired by the papers to solve the difficulties mentioned above and to promote optimized algorithms reading human post models, real databases registered to occurrences and complex environmental effects, etc. in the future. Thank you.